Welcome to this section of this course. Today I will be speaking about derivative of hyperbolic functions. Okay. So what is hyperbolic functions? We already have the details of the video. So today we'll be considering only its derivative of that hyperbolic functions. Okay. Now we know that sine of hyperbolic x equals to e raised to x minus e raised to minus x upon 2, and another is cos of hyperbolic x is e raised to x minus e raised to minus x. Cos hyperbolic x is plus 2. Okay, and this is 1, this is 2. Similarly, you can find tan hyperbolic x by dividing sine by cos. If you divide sine by cos, then 2 gets cancelled. You'll have e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Okay. Similarly, you can find all other derivative functions hyperbolic, meaning this is same as 4. If you have to find cosec hyperbolic x, okay, here cosec of hyperbolic x is just reverse. 1 by sine is cosec, okay, therefore it will be 2 upon e raised to x minus e raised to minus x. And what about sec hyperbolic x? Sec is reciprocal of cos, okay, here just reverse it, 2 upon e raised to x plus e raised to minus x. Sine cos, then cot. Here 6 we have. Cot hyperbolic x is, we can cos by sine or 1 by tan hyperbolic is cot. So just reverse it. Reciprocal of it, e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. Okay. Now our aim is to find derivative of all these hyperbolic functions. Okay, hyperbolic functions. Now let's find what is derivative of, what is d by dx of sine of hyperbolic x. Okay, what is sine hyperbolic x? We have sine hyperbolic x is this. Okay, just write it down. D by dx of e raised to x minus e raised to minus x upon 2. What I am doing is just I am substituting sine hyperbolic x formula, this. Okay. Now since 1 by 2 is constant, I can send outside. This is same as 1 by 2. Okay. Now differentiation of e raised to x. Okay. E raised to x is what? E raised to x minus, again e raised to minus x is what? E raised to minus x into d by dx of minus x is 1. Okay, here we have another minus 1, you can say. Here minus plus. This same as half e raised to x plus e raised to minus x. What is this? Okay, this is same as cos hyperbolic x. Okay, this is what? Cos hyperbolic x, meaning if d by dx of, if you have to find d by dx of sine hyperbolic x, then it is cos hyperbolic x. Okay, similarly this is 1. So you can find cos hyperbolic. Okay, what is derivative of cos hyperbolic? D by dx of cos of hyperbolic x is equals to d by dx of, what is cos hyperbolic? Here we have, okay, here e raised to x plus e raised to minus x upon 2. Here I can take half outside since it is constant. D by dx of e raised to x is e raised to x plus d by dx of e raised to minus x is e raised to minus x. Again you have to differentiate this with respect to x. Okay, here we will get minus 1. And this is half e raised to x minus e raised to minus x. this is this, okay. Therefore, this is what? This is cos of hyperbolic x. This is sine. This is what? Sine of hyperbolic x. Therefore, d by dx of cos hyperbolic x is sine hyperbolic x. Next, let's find d by dx of tan hyperbolic x, okay. D by dx of tan hyperbolic x is equals to, you can apply from here, okay. You can apply what? Either you can do one thing, d by dx of e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. You can do this way, or what you can do is d by dx of sine of hyperbolic x upon cos hyperbolic x. You can do this way, okay. Since we already have this, okay, since we already have this, now d by dx of tan hyperbolic x is, you can use this, or you can use sine hyperbolic by cos hyperbolic x, okay. Let's see. This is let's solve 2s, or is equals to d by dx of sine hyperbolic by cos hyperbolic x. It's like u by v rule, okay. Here cos hyperbolic the whole square, cos of hyperbolic whole square x, here v square cos of hyperbolic x, keeping as it is, d by dx of sine hyperbolic x is, we have cos of hyperbolic x minus cos hyperbolic x, okay, and d by dx of sine, you can use, I am using d by dx of u upon v is v, we have v square v u prime minus u v prime, okay. Now cos hyperbolic whole square, this is v, keeping as it is, okay, here, and then I am differentiating sine of hyperbolic x, okay. Sine hyperbolic x is what? Cos hyperbolic x, okay. Now keeping sine hyperbolic x as it is, okay, and differentiating cos hyperbolic x is what? Sine of hyperbolic x. This is same as cos square hyperbolic x minus sine square hyperbolic x upon cos square hyperbolic square x. This is cos square minus sine square, cos square hyperbolic minus sine square hyperbolic x square is 1 upon cos square cos hyperbolic square x. Why it is 1? Because we have two sine function. It means, remember, we have sine square x plus cos square x equals to 1, okay. Now if you want to know what is hyperbolic, okay, just write down it's hyperbolic. After that you can check the sign is what? Sine hyperbolic square x cos hyperbolic square x is equals to 1. In these identities, just find out those trigonometric functions only which have two sine functions, okay. Here we have two sine functions. In that, change the sign, okay. If it is plus, then minus, then since it is not two sine, therefore plus will be it is, okay. Therefore cos square hyperbolic cos hyperbolic square x minus sine square hyperbolic square x is 1, okay. Meaning you should have two sine functions. In that, change the sign, you will get hyperbolic. All the trigonometric identities, you will get hyperbolic in that way, okay. Therefore this is what? This is, we have 1 by cos is sec square, sec hyperbolic square x. Okay, this is the required answer for tan hyperbolic. Next is, let's find derivative of cos hyperbolic x. Now for dy dx of cosec hyperbolic x is same as dy dx of cosec is what? 1 by sine of hyperbolic x. Apply u by v rule here. U by v rule. Here we have sine square hyperbolic x, sine hyperbolic square x, keeping here, sending here sine hyperbolic square x minus, okay, into sine hyperbolic square into dy dx of 1, I will write everything, minus 1 into dy dx of sine of hyperbolic x. This is what we are applying u by v rule, okay. dy dx of x is constant, therefore whole this term will be 0. And what we have minus dy dx of sin x is what? Cos of hyperbolic x upon sine of hyperbolic square x. Now sine hyperbolic square x we can write 2 times is minus cos of hyperbolic x upon sine of hyperbolic x into 1 upon sine hyperbolic x. Cos by sine is what? We have cot. Cos by sine is cot of hyperbolic x into 1 by sine is cosec. Cosec of hyperbolic x. Therefore, dy dx of cosec hyperbolic x is minus cot hyperbolic x into cosec hyperbolic x. Okay. Now let's check 5. Cosec sec dy dx of sec hyperbolic x. It is same. Sec is what? 1 by cos. Okay. Here 1 by cos of hyperbolic x. Here you apply u into v, u by v rule. We have cos of hyperbolic square x. This cos hyperbolic square, okay, cos hyperbolic x into, I will write down, cos of hyperbolic x into d by dx of 1 minus 1 d by dx of cos of hyperbolic x. Now here d by dx of x is what? D by dx of 1 is 0. Okay, here 0 into cos hyperbolic x is become a 0. Okay, d by dx of cos hyperbolic x is, we have sine hyperbolic x. Okay, here we have sine hyperbolic x. And cos hyperbolic square is same as, we can split sine by cos square, we can write 2 times into cos of hyperbolic x. Here I can write minus 1 over here, sending, and this upon this and 1 upon this. Therefore this is same as minus 1 by cos is what? Sec. Sec hyperbolic x. Sine by cos is, sine hyperbolic by cos is 10. Sine by cos is 10 square 10 hyperbolic x, or you can say sechx 10x. Okay, you can write sec hyperbolic x into 10 hyperbolic x. dy dx of sec hyperbolic x is minus sechx sec hyperbolic x into 10x. Next, let's find what is derivative of cos hyperbolic x. Okay. Now 6 d by dx of cot of hyperbolic x is same as, cot is same as cos by sine. Cos hyperbolic x upon sine hyperbolic x. Applying u by v rule here, sine of hyperbolic square x, keeping over here, sine of hyperbolic x into d by dx of cos of hyperbolic x minus cos hyperbolic x into what we have to differentiate? Sin x, sin hyperbolic x. Sin of hyperbolic x. Here, dy by dx of cos hyperbolic x is sin hyperbolic x. Okay, sin into sin is sin square hyperbolic x minus. Here, what we have is cos square, cos hyperbolic x. Here, what we have is cos. Here, we'll get cos square, cos hyperbolic square x upon sin of hyperbolic square x. Here, we have, as I told you, we have sin square hyperbolic square x minus cos hyperbolic square x plus equals to 1. Here we need minus over here. Okay, in order to apply this one, we need minus over here. So I am multiplying, sending minus inside. If I send minus inside, this become minus, this become plus. Okay, therefore this become a 1. It's minus 1 upon sine of hyperbolic square x. This is 1 by sine is what? Cosec minus cosec hyperbolic square x. Okay.